Students, in this video, we are going to look at lag compensator and lag lead compensator. So, first point in lag compensator is it is something which is complementary to the lead compensator. The lag compensator will improve the steady state performance of the system while not disturbing the transient performance. Okay, so it is meant for improving the steady state performance. Somebody who likes to improve the steady state performance rather than the transient state performance, then they can go for lag compensator. The lag compensator transfer function is like this. Okay, it might look like similar to lead, but it is not so, because the ratio ZC by PC, which is equal to beta, should be greater than 1. Okay, should be greater than 1. If for example you take the 0 location as 1 by tau, then your pole should be located at minus 1 by beta tau. Okay, when you say beta is greater than 1, that means you take a randomly at a location at this location as 0, then obviously your pole will be towards the right hand side. That is, the pole will be nearer to the j omega axis compared to the 0 location. So such kind of compensator is called as lag compensator. So what it is? The pole will be nearer to the j omega axis compared to the 0. Okay, so this kind of compensator is called as lag compensator, which is going to improve the steady state performance of the system. So here is again an example, electronic example, but for lag compensator R1, R2, and C. Similarly, V1 is the input and V2, that is the voltage across this series combination R2 and C, is your output voltage. Okay, so the transfer function V2 of S by V1 of S is given by this expression. Okay, if you want to solve, you can just take do a Kirchhoff's voltage law and apply mesh analysis to get the transfer function. Okay, so slightly rearrange such that it is of the form 1 plus tau s divided by 1 plus beta into tau s. So if you just rearrange it, then you will get beta as R1 plus R2 by R2. Select R1 and R2 such that it is greater than 1. Then you will get a lag compensator. So the selection of the components, that's what's called as a design of a compensator. Okay. So if it is selected greater than 1, then it will be acting as a lag compensator. So similarly, we have just taken the sinusoidal transfer function of lag compensator. Okay, that is replacing S by j omega, and we have drawn the Bode plot. Okay, so by this time you should understand that there will be a phase lag introduced by this lag compensator. That means the phase will be in negative. Okay, so if you look at the phase plot, the introduced phases, that is the phase of this compensator, is negative. When you introduce to a system, then it will introduce a negative phase to the current plant, isn't it? So it is called as lag compensator. Okay, because the phase is in negative. The formula for computation of this phi, that is beta from phi m or phi m from beta, is similar to the one that we have given in the previous video. That is, sin phi m is equal to 1 minus alpha divided by 1 plus beta, isn't it? So here also, instead of alpha, it is beta. But only thing is, beta is going to be greater than 1. Okay, so the same formula you can use if they are going to give you what is the phase, maximum phase that has to lag in the particular system, then you can use this formula to find the value of beta. Once the value of beta is known, then you can easily locate the 0 and the pole. Okay, so that you get a compensator. So this is about your lag compensator. Suppose if you want to improve both transient performance as well as your steady state performance, then you have to go for a compensator like lag lead compensator, which will take a transfer function of this type. Okay, which will take a transfer function of this type. Okay, 1 by tau 1, 1 by beta tau 1, 1 by tau 2, 1 by alpha tau 2. Okay. So if this is one location of 0, then the corresponding pole location is this. And if this is another location of 0, then there is a corresponding location of pole. Okay. So there are two pairs now, one pole 0 pair and another pole 0 pair. But alpha and beta cannot be independent. Okay, they cannot be independent. So it has to be, I have some relationship. So let us take it as alpha into beta is equal to 1. That means that alpha is equal to 1 by beta. So you can see that actually this should be 1 by alpha tau 2. Am I right? But instead of 1 by alpha, they have given it as beta. Okay, there should be some relationship between the alpha and beta. Okay, so this is how the pole 0 locations will be for lag lead compensator. As I said, we are not going in depth, okay, in the design of the compensators. So we are just giving the transfer function of the compensators, its location of poles and zeros, and an example in electronic domain. Okay, so that's what we are trying to do here. In-depth reading students can do in the material given. So this is one example of lag lead where you can see that both arms are having RC and RC. So if you want, you can take the transfer function and compare it with this transfer function of lag lead compensator and find the values of alpha, beta, and tau 1 and tau 2. Okay. So with this, we are closing the compensator.